Physics Part 301. Charging and discharging capacitors. The circuit in figure can be used to investigate what happens when a capacitor is connected to a battery. Start with the lead to battery terminal A connected, but that to be disconnected. When connection is first made to terminal B, both emitters flick to the right and then return to zero, indicating a momentary pulse of current. If the process is repeated, then nothing further happens. The capacitor has become charged. During the initial connection, the emitter have similar deflections. I beg your pardon. The emitters have similar deflections. This tells us that the same charge has moved onto the left-hand plates as has been removed from the right-hand plate. The momentary current has caused the left-hand plate to acquire a charge of plus Q, while the right-hand plate has a charge of minus Q. The capacitor is now set to store a charge of Q, although if we add up the charges on the left and the right hand plates taking account of their sign, the net charge is always zero. There can be no steady current because of the gap between the capacitor's plate. The current stops when the potential difference across the capacitor is the same as the EMF of the battery. When the battery lead to terminal B is disconnected and joined to the point A so that the battery is no longer in the circuit, the opposite direction has moved the charge of plus Q from the left-hand plate to cancel the charge of minus Q on the right-hand plate. The capacitor has become discharged. Remember that in metal wires, the current is carried by free electrons. These move in the opposite direction to that of the conventional current. That's what we have already explained. When the capacitor is charged, the electrons move from the negative terminal of the battery to the right-hand plate of the capacitor, and from the left-hand plate to the positive terminal of the battery. When the capacitor is discharged, electrons flow from the negative right-hand plate of the capacitor to the positive left-hand plate. The experiment described using the circuit in the figure showed that there is a momentary current when a capacitor discharges. A resistor connected in series with the capacitor will reduce the current so that the capacitor discharges more slowly. The circuit shown in the figure can be used to investigate more precisely how a capacitor discharges. When the two-way switch is connected to a point A, the capacitor will charge up until the potential difference between its plates is equal to the EMF of V0 of the supply. When the switch is moved to B, the capacitor will discharge through the resistor. When the switch makes contact with B, the current can be recorded at regular intervals of